In talking about part 2 of soil erosion as source of contaminants, I want to talk about 3 types of erosion. I have alluded to these previously, but we can characterize erosion as sheet erosion, rill erosion, and gully erosion. Sheet erosion, as is implied in the photograph, is erosion that occurs as water sheets across the surface of the land. In other words, we don't really have a channelized flow. Rather, the water is just moving sort of as a large mass across the surface of the land. As it moves, it picks up it detaches particles, and it transports those particles from their original source to a new location, which presumably is downhill, and over time then can be a process of moving particles from upland source areas to bottomland sink areas. Rill erosion occurs when the sheet flow begins to concentrate into rivulets, or what is called rill flow. These little lines that you see in the center diagram are rills, and notice that they are wider and deeper at the bottom of the hill than they are at the top of the hill. That's because as the water flows downhill, it becomes concentrated in the rill channels and its velocity increases. Consequently, the capacity of the water and the particles that it's carrying to incise channels and erode channel walls or rill walls becomes stronger. Finally, the rills begin to concentrate into gullies, and the same process occurs where concentration of rill flow into gully flow, lateral gully erosion causes significant erosion of channel walls, and vertical gully incision causes significant erosion of the channel bottom. So the transportation of detached particles results then in the deposition of detached particles from upland source areas into bottomland sink areas through these 3 processes of soil erosion. The diagram in the upper left gives you a sense in the top left of how much soil, in this case, has actually been eroded by sheet flow. Sheet erosion can be quite significant. Here we see almost 2 inches of topsoil that has been removed from this field by the action of sheet flow, water sheeting across the landscape. And then we can see the sheet flow coming off of an agricultural field in the second diagram, discharging into an adjacent stream, carrying all of the sediment that has been detached from the upland area, depositing that into a bottomland sink area. Over-enrichment of water bodies by transport of nitrogen and phosphorus from upland sources to bottomland sinks creates a process of what's called eutrophication that degrades water quality and kills aquatic life. Essentially, what this diagram is suggesting is that nitrogen as a soluble substance and phosphorus as partially a soluble substance and partially a substance that's attached to soil particles are carried by water into a water body, a wetland system or a river or stream or a lake or impoundment. As these nutrients are discharged into the water column, they have a tendency to increase phytoplankton, the growth of algae within the water body. Growth of algae will eventually shade out submerged aquatic vegetation on the bottom of the lake, and that dying submerged aquatic vegetation then dies off, and the process of decomposition as the submerged aquatic vegetation decays robs the lower portion of the water body of oxygen, causing an anoxic condition that reduces habitat for fish and other animal species. Also, the increase in phytoplankton, the algae bloom, as we call it, eventually the bloom dies off, and the organic material then sinks to the bottom, where it again undergoes decomposition, decay and decomposition, taking oxygen out of the water, making conditions anoxic and potentially lethal to species dependent upon oxygen in the water column. So these processes of eutrophication are a product of nitrogen and phosphorus moving from upland source areas into contaminant sinks by the detachment and transport of particles and deposition of particles from contaminant source areas to contaminant sinks. Many natural sources of nutrient inputs to water body produce a gradual rate of natural eutrophication of a lake. The problem is that sometimes human activity, such as urbanization or agriculture, can lead to rapid, what's so-called cultural eutrophication that accelerates the discharge of phosphorus and nitrogen inputs from upland source areas into bottomland sinks. Natural eutrophication occurs over many centuries, and it's the process through which a pond or a lake, over many tens of years or many decades, becomes filled, and when it becomes filled, it transforms itself into a marsh or a bog, and eventually into a wet prairie or a forest landscape. This is a natural process, but it's a process that has a time frame that's measured in centuries rather than in years or decades. Cultural eutrophication, the process whereby nutrients are moved at an accelerated rate into water bodies, that process can take decades or years. And so the process of cultural eutrophication is much more rapid than is the process of natural eutrophication.